So here's our other special case in section 3.8, factoring difference of squares. So if we have these two binomials, x plus 5 and x minus 5, and we multiply them out, we're going to multiply this out using FOIL because it's a binomial times a binomial. So I'm going to go first, outside, inside, last. I'm going to get x squared minus 5x plus 5x minus 25. And if I simplify, minus 5x plus 5x, well, that becomes 0, so I just get x squared minus 25. If I do this other example, 2y minus 3, 2y plus 3, same thing, FOIL, first, outside, inside, last. I can see I'm going to get 2, no, sorry, not 2, that's going to be 4y squared plus 6y minus 6y minus 9. Well, plus 6y and minus 6y, that cancels to 0, so I get 4y squared minus 9. Now the key here is to see a couple of similarities between these two types of questions. If I'm expanding x plus 5, x minus 5, the only thing different between the two is that one's a plus and one's a minus. And how does my question end up? Same with my second example. 2y minus 3, 2y plus 3. The only difference is this is a minus and this is a plus. How does my question end up? I end up with a binomial that has some special characteristics. Special characteristics are, well, A, it's a binomial, only two terms. The terms inside are separated by a negative sign. This is a perfect square. This is a perfect square. So if I were to factor x squared minus 25 into a binomial times a binomial, I'd very easily be able to go right back to here. Notice though, minus here, so one's going to be plus, one's going to be minus. Square root of 25 is 5, and the square root of x squared is x. Okay? Wow, that got messy really fast. So just kind of keep that in the back of your mind as we work through the rest of these examples. I'll do the first examples here, and then I will pause the video. I'll make a second video with the last couple of examples. So if you're working backwards to factor difference of squares, first you have to recognize that it's a difference of squares. Is it a binomial subtraction of perfect squares? What does that mean? Is it a binomial, two terms, subtraction of something that is perfect squares, 4y squared and 9? Okay. Once it is, what do? You take the square root of the first term, take the square root of the second term, and then write your product out as one being plus and one being minus. So let's have a look. Factor d squared minus 49. First thing, is it subtraction? Yes. Is this a perfect square? Yes. Is this a perfect square? Yes. So we've met all those terms. So now I simply take the square root of d squared, which is d. I take the square root of 49, which is 7. I make binomial brackets with both. I make 1 plus and 1 minus. And it makes no difference which one is plus and which one is minus. Question B. 25 minus 144 x squared. Ask yourself the same questions. Is this subtraction? Yes. Is this a perfect square? Yes. Is the first term a perfect square? Yes. So we've met all of our properties. I take the square root of 25, gives me 5. I take the square root of 144, gives me 12x. 144x squared, I mean, gives me 12x. Bracket, bracket, make a second bracket with the same thing. Make 1 plus, make 1 minus. Done. Question C. 36a squared minus 81bc squared. Now, remember, this isn't going to be too much of a problem because, well, let's figure it out first. Is it subtraction? Yes. Met our first characteristic. Is our first term a perfect square? Yes, it is. Is our second term, 81b squared c squared, a perfect square? Yes, it just happens to have two variables. Well, what is the perfect square, or the square root of 36a squared? 6a. What's the perfect, or the square root of 81b squared c squared? Well, that's going to be 9bc. Bracket, bracket, Make a second one, 6a, 9b, c. Make one plus, make one minus. Done. Now, if you didn't want to remember all of those steps, you could easily work through these factoring questions of two terms by simply just filling in, and I'll do this in purple down here, simply filling in a zero term for the middle term that's not there. So d squared minus 49 could also be written as d squared minus 0d minus 49. Well, now I can factor this like I have in the past. I look for two numbers that multiply together to give 49, negative 49, and those same two numbers add together to give 0. Well, what are those two numbers? Plus 7 and minus 7. So I write my binomial brackets. I put my d in, make one plus 7, make one minus 7, and we ended up exactly at the same place. So you could do these questions without having to remember those rules or those steps with difference of squares, but it just makes it a little bit easier. Okay, so I'll pick up the next two examples and our last set of examples for 3.8.